Hello everyone, welcome back to my channel. My name is Piyush and this is video number 34 in the series CK 2024. Yes, we have come a long way and thank you for all the love and support that you have shown till now. I'm sure you will continue doing that, and our job here is not done yet until it's actually done. We still have a few more videos pending. We still have few important topics to cover, and those are really important ones. For example, in this video, we'll be looking into how we can upgrade a Kubernetes cluster end to end, like control plane components, worker nodes, and everything. And it is an important task for any Kubernetes admin, or in some organization, it is done by DevOps engineer or sysadmins. Irrespective of that, we'll be covering all that. We'll be doing all the hands-on in this video, and the comments and like target of this video is a little high, so I am aiming for at least 300 comments and 300 likes in the next 24 hours. I'm sure it will be a piece of cake for you. So without any further ado, let's start with the video. All right, so let's have a look at one scenario. So I'm going to explain a few concepts before we look into the actual upgrade process. So let's say we have a 3 worker nodes and a master node. So a 4 node cluster, and it has few workloads running. So let's say we have Nginx, and this Nginx is a part of deployment. So we have 3 replicas, 3 pods running in each of the nodes. Let's assume I'm gonna keep it over here, and then because it's part of a deployment, let's denote that with the dotted line, and everything is part of one single deployment which is controlled by the deployment. Okay, so I'm gonna just name it nginx deploy. Okay, and then we have, let's say, one more pod. Let's call it a MySQL pod. And this pod is not managed by a deployment or a replication controller or a replica set. It's just one single independent pod running on one of the nodes. Okay, let's say worker node 1. Now, what we have to do, let's say we have to, for some reason, take out worker node 1 for some maintenance task, for, or let's say the node is broken and we have to replace it with a new node, with the node that is not broken, which is in a good state, right? So the ideal state is we have to evict the running pods, okay, from this node, and then replace it with a newer node. For that, we use something called as drain process, right? So we actually write this command node, and then node name, which is worker 1, and drain. So we are actually draining the node. Draining the node means we are emptying it. We are evicting all the workloads that is running on the node, right? So we'll evict this, because this nginx pod, let's say it's evicted from the node, but this is managed by a deployment. So as soon as the controller finds out that the desired number of replicas was 3 for this deployment, the actual is 2. So it will spin up a new pod in one of the available nodes, right? And why not this? Because we have already drained the node and marked this as unschedulable. And why on not on this node? Why it has scheduled the pod on this node or this node? It's because we have drained this node, worker node 1, and we have marked it as unschedulable. So we actually did two things over here. We actually drained it, that means we have evicted the running pods or running workloads, and we have marked it as unschedulable. That means no new pods will be scheduled on this node, right? So it actually did draining. Let me write it down over here. So it actually did draining, which is same as evicting the pods. And we actually also cordon the node. Cordoning means mark it as unschedulable, right? So we actually, with this command, we actually did these two things. Now this particular node is cordoned, that means unschedulable, and also it is drained, that means there is nothing running over in this node. But we also had this pod. So before marking it as drained, controller also evict this pod as well. But because this pod is not managed by a deployment or application controller or any of the controller, so this pod will be gone forever. This pod will be deleted, this pod would not be recovered, right? So data inside this pod or anything configuration related, it will be gone forever. So we need to keep that in mind, right? So this pod is gone now, but this pod has already scheduled on this node, so we are good with that part. Now this deployment only spans 2 nodes, and this particular worker node is out of the picture now. We cannot schedule any new pod. So let's say we schedule a new pod, let's say a Redis pod. Now this Redis pod will be scheduled on this node or this node, right? It won't be scheduled on worker node 1 because it is already cordoned. It is already unschedulable. We cannot schedule anything unless it is in that state. So now once we did that, once we okay, and then we applied some upgrades on this node, or let's say we replaced it with a newer node, then we have to mark it as uncordoned again, right? So what we'll do is node worker node 1 and uncordon. So this will make the node schedulable again. So now it is ready and it is able to schedule the new workloads. So now if we scheduled let's say MySQL pod again, it can be scheduled on either of the 3 nodes. Remember, when we mark the node uncordoned from the cordon state, it will not schedule the already running pod, right? So this pod that was moved from worker node 1, right? And then it was moved to worker node 2. Actually, it was not moved, it was evicted from it gracefully, and then a new pod was created on this node, right? But it doesn't mean that whenever we have the node 1 ready, this pod will be moved automatically back to it. No, it won't happen. The new pods will be able to schedule on this node. This node is now part of the cluster again. This node is now healthy again, and it will be ready to serve the workload. So that's what it means. So this concept is really important: drain and uncordon. So remember, when we drain a node, we actually doing 2 things. One is draining it and then cordoning it. We are evicting the existing pods, existing workload from that node, and we are also making it as unschedulable so that no new pods will be scheduled on that node. We are taking this out of maintenance, and then we can mark it as uncordon whenever the node is healthy, whenever we have done our task that we were supposed to do. So then the node become healthy again. So that's the concept of cordon, drain and uncordon. So this is important because we'll be using this concept while upgrading the worker nodes. So that's why I wanted to cover it first. So let's have a look at all the components involved in the upgrade, what is the release and the format of it. So I'm going to scroll down. So let's say the current version that I'm using currently is 1.30.2, right? So it will be in this format where the first part over here is the major release. This is called a major release. And let me just squeeze this a little bit. Okay, this is a major release. Then we have minor release. Okay, this is the minor release. And then we have the third one, the third part of this release version. And that third part is called a patch, right? So till the time Kubernetes is in picture, we are using version 1 as the major release. There hasn't been any change to that yet. And after every few months, Kubernetes release a new minor version. So 1.29, 30, and then there'll be 1.31 and so on, right? So this is really frequent. In, like, let's say 2-3 months, we get a newer minor version, and the patch versions are more frequent. So we get this for any bug fixes, for any minor enhancements, something that can be done with a few file changes, and something that does not have a release wide impact, right? So these are the frequent changes that happen for bug fixes mostly, right? And this is what we upgrade. So when we do an upgrade, we actually upgrade the minor version, right? Minor version and patch along with it. So we have some policies that we have to keep in mind. For example, if we are upgrading, let's say from 1.30, we don't have 1.31 as of today, but let's say we have 1.29.2, or let's go one minor version back. So we have 1.28.2, okay, and then we have 1.29.3, and then we have 1.30.2, let's say. So we have to, let's say, upgrade from 1.28 to 1.30, right? As per the version queue policy, we cannot upgrade directly from 1.28 to 1.30. First, we have to upgrade from 28 to 29 over here, right? And then once that upgrade is done, then we have to upgrade from 1.29 to 1.30. So one minor version at a time. So you see over here, we are upgrading one minor version at a time. We cannot skip the version. That's the important part. So in exam, or like in as a Kubernetes administrator, if you were given a task to upgrade from 1.28 to 1.30, keep in mind you have to go one minor version at a time. So 1.28 to 1.29, then 1.29 to 1.30, and so on. So if there were multiple minor versions, then yes, this is the same practice that we have to follow, one minor version at a time, right? And yes, I understand it becomes a cumbersome task when you have to move from 1.26 to 1.30, like five versions at a time. You have to do one by one. But that is why we need to ensure that we regularly upgrade our Kubernetes versions. And as I've mentioned, that in every 2-3 months, we have a new minor version available. So this become a more frequent task for any Kubernetes admin. Let's say every month or every couple of months you have to upgrade your cluster, and if you have, like, let's say hundreds of cluster running in your environment, then this task require a team to handle this, or we need some sort of automation to do this upgrade process seamlessly. So that is why it is an important task for a Kubernetes administration, because it is very frequent in nature and it is really important. And why this is important? Because let's say, let's take this example, 1.29 and 28 1.30. So at single time, Kubernetes only support three minor versions. So let's say we are supporting 1.28, 1.30. As soon as the newer version 1.31.1 is available, right? This is available. So we only get support of three latest versions, which is from 1.29 to 1.31, right? And this version 28, this will be out of support. Out of support does not mean that you won't be able to use it. Out of support means there won't be any new bug fixes, there won't be any new enhancement made to the version that is out of support. We can call it out of support or end of its life, whatever we want to call it, but it is not supported anymore. And Kubernetes only support three latest minor versions, 1.29, 30, 1.31. If you want to understand it from a branching perspective, so we have three release branches, 29, 30, and 31, and then the code will be merged to the master branch once these three branches are completed. And this branch will be deleted as soon as there is a newer branch available, right? So that's how it works. Now you can look at the documentation over here. We'll be looking that in detail, but now it also says the same thing over here, that to upgrade the version from this to this, where y is greater than x, skip the minor version. If it is not, if it is unsupported, only then we can skip it. Otherwise we have to do from, let's say, 28 to 29, 27 to 28, and so on, right? So this page shows how you can upgrade the Kubernetes version. Now there are some steps involved, like how do we upgrade it, like the process of it. So first we'll have a look at this and then we'll do the demo. So it says at a high level, you have to first upgrade a primary control plane node, then additional control plane node, and then worker node. What do we mean by additional control plane node? Currently, the cluster setup that we have is one control plane and multiple worker nodes, but this is not a high availability cluster. Why? Because if we go and have a look over here. So let's say if our master node is going through upgrade or it is down for some reason, then all the management functions will be impacted for all the worker nodes, right? Because this node, master node, is responsible for doing all the administrative tasks, like to make sure that the desired number of replicas are already available with the help of controller. Master node is down, that means all the control plane components will be down, your controller will be down. To create a new pod or to get the pod, to delete the pod, you have to interact via kubectl utility, which again calls API server. API server will also be part of master node. This will be down. So we cannot do any administrative task, but your existing workload will keep on running, right? Your application will not be impacted unless there is an issue, right? So in that case, what we do is we usually deploy our cluster in high availability mode. High availability mode means multiple master nodes, like we have multiple worker nodes, right? For high availability of worker or for the workloads. That is the same reason why we deploy our cluster with multiple master nodes, so that if one master is down, other masters are able to serve the traffic. And we actually put a load balancer in front so that traffic will be distributed to the API server on multiple master nodes, right? So that is what it mean over here, like to upgrade the cluster, upgrade the primary node first, and then additional control plane nodes, the additional nodes that we added for high availability, and then we upgrade the worker nodes, right? To upgrade the worker nodes as well, we can follow some upgrade strategies. Let's have a look quickly. So let's say we have these worker nodes. I'm just gonna copy it from here. Okay, so we have, let's say, 3 worker nodes, we have to upgrade it. So first is we can do all at once. Okay, that means currently, let's say if it is running version 1.29. Not 39, 1.29.1, this is the version on all the worker nodes at the moment, and we have to upgrade it to 1.30. So what we can do is we can upgrade all at once, bring the node down, and we can start all the nodes. So first, what we'll do is we'll drain all the nodes, right? And then we upgrade all the nodes, and then we uncordon all the nodes so that it will be healthy again. But the time that it takes for the upgrade, the time between the drain and the upgrade and before we do the uncordon, these nodes will be unhealthy and unschedulable. That means our user will be impacted. So this is not a recommended strategy for doing the upgrade, in at least in the production cluster. And then we have a different way, the other way, other upgrade strategy, which is rolling update, right? In rolling update, what we do is we do one at a time. So let's say we drain worker node 1, we do the upgrade. Let's say now this becomes 1.30.1 or 2, whatever it is, and then we uncordon it. While this node is upgrade in progress, the users are not impacted because worker node 2 and 3 are still available. Now once this is done, we do the same on worker node 2, upgrade it to 1.30, and when this upgrade is going on, 1 and 3 will be available. And then we do the same in worker node 3, 1.30.1, and this will be done. So all the worker nodes will be updated. Rolling update, that means one at a time, right? And then we have the third upgrade strategy, which is called blue green as well, right? Or additional infra setup and so on. So whatever you can call it. So in that, what we'll do is, let's say we were on version, I'll just make the changes again quickly, 1.29, 1.29, 1.29. Okay. So what we'll do is we'll create a new infra, right? We'll provision additional 3 nodes. Okay. And we call it, and in that we install version 1.30, the version that we want to upgrade to. So there is no upgrade, it's just the installation of a fresh Kubernetes version, the newer Kubernetes version on the newer nodes. And then we have our control plane node over here. So this is our master node, right? Currently, these worker nodes are joined with this master. So what we'll do is, as soon as these new nodes are ready, we actually delete these nodes. Okay. So these nodes will be deleted. Let me delete those. Okay. And these new nodes will be joining the master as the worker nodes. So this approach, the blue-green approach, has few advantages. For example, the upgrade time is less. We just have to join the new node, and we can do that one by one, right? You don't have to do all at once. You can join this worker node to this to this to this, and once they are joined with the cluster, you can delete the existing nodes. I actually did the other way around. The nodes will be deleted after these new worker nodes will join the cluster as the new worker nodes. And once that is done, you can delete the existing nodes, right? So it will be faster. There will be almost no impact, maybe just for a few seconds, and that's all about it, right? It is, if you consider this, it is a combination of rolling update and blue green, right? And the only downside of this upgrade strategy is you need to provision the extra infrastructure. It will be quick if you are using a managed service such as GKE, AKS, EKS, or let's say OpenShift, anything that is managed by a cloud provider. It is easier to provision the infra, or it is easier to add new nodes. But when it comes to on-premises infrastructure setup, this is not recommendable. Like when we work somewhere in an organization, let's say the servers are hosted on a private data center, it actually requires a lot of approvals. It actually takes a lot of time to procure new VMs, and that is why sometimes this approach is not recommendable on those scenarios. But otherwise, it's a really good approach. It saves times. It has a lower impact on the application that is serving the traffic to the user, right? So that's the upgrade strategy. What we'll be doing is we'll be doing rolling update one at a time. Okay, so I guess it's time we can start the upgrade. So I have started my EC2 server. So I have set up this infrastructure in one of the previous videos where I did the Kubeadm installation on virtual machines running on cloud. This is not a managed service by cloud, but it is just I'm using the virtual machines. I have created one master node and couple of worker nodes, joined worker nodes with the master, and I'm self-managing this. Basically, it's not a managed service. I do have access to control plane, and I'll be doing everything on that. Um, so you can check out the video if you know how. If you are not aware of how do we install that. So let's start with the upgrade process now. Okay, so I have logged into my Kubernetes cluster, and this is the master node that I have SSS into. So if I do kubectl get nodes, okay, you see we have a version over here v.1.30.2. So this is the kubelet version, and every component has a different version. So if we go over here, so we have, let's say, 1.31 is currently in alpha. It's not available to be upgraded. So let's go to change log of 1.30, right? And go to this downloads for 30.0. So this is a Kubernetes source code, and it has every single binary. The binary will be like a different control plane component. So these are all the images contained in that binary. So we have conformance, Kube API server, controller manager, proxy, scheduler, kubectl, and so on. So you see, every single binary has a dedicated version, right? 1.30.2. They can be on a different version, but because we are installing it as a package from the source code, it is a same version, right? And we have to upgrade all those components. And you see, Kubeadm is not part of it. So we have to upgrade Kubeadm separately, and kubectl also. It's there in this, but when we apply the changes from Kubeadm command, kubectl and Kubeadm and kubelet are not part of that. So we have to upgrade those separately, right? And there is one more thing. When we do the upgrade, Kube API server, so the primary component has to be on the highest version. Like I said, these components can be of different versions. So let's say our Kube API server is on version 1.30. So our controller manager or our Kube scheduler can only have one previous version. So that means 1.29. And the other components can go at max two previous versions. That means 1.28. Right. So we need to keep that in mind. Let me just write it down over here in case I'm not clear enough. So let's say our Kube API server is on 1.30, right? And this version, let's call it X version, right? And then we have other components such as scheduler, and then we have controller manager. So these can only go to X minus 1, X minus 1, and the other components that we have, kubelet and kubectl, these can go up to X minus 2. So this will be 1.29, this will be 1.28. That's the max it can go. Otherwise, there will be the compatibility issues. But in an ideal scenario, we keep everything to the same version, 1.30 or whatever it is. So yeah, that's what we need to keep in mind. Okay, so now that we have seen, we have different components for every single component. And this is the version of the kubelet. As part of the upgrade process, first what we have to do is, let's go over here. First, determine which version to upgrade to. So if you are in Ubuntu, Debian, or this Hybrid OS, I'm not sure what that is, but if you are on any of these OS, you can run these commands. If you are on CentOS, RHEL, or Fedora, you can run these commands and see what all versions are available. How do you check like which version you are using? So you actually do a cat etc, and then there'll be a release file. So releases, I guess this is it. Oh, not that. So let's go inside etc and let's do ls. Okay, it's OS release. So if you cat on OS release, this will show you the OS you are using. So I'm using Ubuntu. It says Ubuntu 24.04. That's what I'm using. So I can use the first command over here, this one, right? So if I run this, it will show you which version you can upgrade to. So let's run these two. We are doing a sudo apt update and sudo apt cache Madison Kubeadm. So now it is showing me that I can upgrade to Kubeadm 1.30.2 hyphen 1.1. I'm currently on hyphen like 1.30.2. So this is just a minor patch upgrade that we'll be doing. And with the next command, we'll be able to upgrade the Kubeadm. Now, after the Kubeadm is upgraded, we have to upgrade the control plane nodes. So for that, we run a command over here. If you go sudo upgrade plan. So let's run this. And I'm not running the Kubeadm upgrade now because I'm going to show you why I'm not doing it. But first, let's run Kubeadm upgrade plan. It will do the cluster health check and it will actually show you what all the latest versions are available for you to upgrade. So currently it is saying fetching available version to upgrade to. Cluster version is this 30.0, Kubeadm version is the same, and target version is also the same. That means I am at the latest version in 1.30 series. So that is the reason I cannot upgrade it to. Now what I need to do, because I have to do this demo, right? I'm recording this video, so I have to show you the demo. That's why you are here. So what I'll do, I'll provision a new cluster with 1.29 so that we can upgrade to 1.30. So let me pause the video, let me do the installation again, and then we'll come back and see the upgrade. Okay, so I have installed a new Kubernetes cluster with version 1.29.6, and I have joined my worker nodes with the master node. So if I run kubectl get nodes, I see there are 3 nodes, 1 master, 2 worker, and the version is 1.29.6. Okay. Now what we need to do, we need to follow this document to perform the upgrade. This is the default document, the one that you see on the home page, because current version is 1.30.2. So that is what it is showing, that this page will explain how to upgrade a Kubernetes cluster with Kubeadm from version 1.29 to version 1.30. So this is what we need to do. But if you have an older version running, so you can follow the other documents 1.28 to 29, 27 to 28 and so on. Okay, so we'll start with the primary control plane node. Before that, let's go ahead and follow this document. It says if we are using a community owned package repository, which is package.kh.io, you need to enable the package repository for the desired Kubernetes minor release. What it says, you go over here in this document, the link is already there, and you have to verify if you are using a community owned package version, right? So scroll down, and if you run this command, it will show you the results. So let me run this command, and it is returning this results. So we are using packet.kh.io, that is a community owned package version. So that is true. Now, if you want to see the available list of packages, you have to update this file to the minor version for which you want to see the available packages. Like it is 1.29 now, we have to change it to 1.30. So which file is responsible for that? This file over here, etc apt source list d kubernetes list. Yeah, okay. So instead of pager, I'll just update this command to sudo vi, because we wouldn't have access to it otherwise. So sudo vi, and I'm gonna move it into insert mode, change 1.29 to 1.30. Okay, once that is done, let's follow this document again. And now it says to run sudo apt update. Let's do that, and then run sudo apt cache Madison Kubeadm. Then it will show you the available Kubeadm packages. So if we run this, it says these are the packages available: 1.30.2, 1.30.1, 1.30.0, and so on, right? So we'll start with this one. Okay. Now it says run this command. I'm not sure if it is too small, but okay, let me just increase the size of this window. Okay, should be better now. Okay, so it says replace Kubeadm version over here, right, with the version that is available. So let me copy this command to a text editor over here. Okay, and now we need to update the Kubeadm version over here. It was 1030.2 slash, we need to enter the complete name, slash 1.1. Okay, so 1.1. Okay, and then it will install this Kubeadm version, right? So let me copy this command and let's run this now. Okay, I guess there is because I've copied the command from documentation, there is a this comma that has been changed to something else. Okay, this should run now. Okay, let's see the Kubeadm version now. It should be 1.30. Okay, so if I run Kubeadm version, it says 1.30. Major is 1, minor is 30. Okay, and here is the git version 1.30. All right, so Kubeadm version is running fine. We have upgraded. Now we need to run this command, Kubeadm upgrade plan. This will show you the upgrade plan. Like this is not applying the upgrade, but this will be just showing you the dry run, and this will show you different metadata. So we'll explain that. Let's run this. As always, it is running some cluster health checks, and now it has spitted a lot of details. So let's look at that one by one. And this is really important. So if you see, the cluster version is 1.296. That's correct. Kubeadm version is 1.3, 1.30.0, which is what we have upgraded just now. And the target version, this is the target cluster version, is 30.2. Okay. Now it says kubelet the version of different component. Kubelet version is also 1.296 and we have to upgrade it to 1.30.2, which is the target version. But it says over here components that must be upgraded manually after that you have upgraded the control plane. So this kubelet has to be upgraded manually. Like we have upgraded Kubeadm, we have to upgrade this manually after the upgrade is done. And then it says different components. So we have different components: API server, controller manager, scheduler, proxy. So these are on the same version, and then the target version is 1.30. And these two components, core DNS and etcd, because they are a separate project, that's why it is version separately of Kubernetes. So it has a different version, 1.1.1, and this is already on latest, so we don't have to do anything for that. Okay. Once you've verified everything, once you are satisfied with it, you have to run this command to execute the upgrade. All right. So let's follow the document again and let's see what it says. Okay. So we have run it already. And now it says to run upgrade apply version, whatever version we want to upgrade to. So let's copy this command from here. Okay. And I'm going to execute this. It says permission denied on kubeconfig file. All right, so maybe that file does not have permission. So let's grant it some permission. Sudo chmod 775. Okay, let's run it again. Okay, now it's saying a user is not running as root or privileged user. So I'm going to add sudo in front of the command and this should run fine now. So this will upgrade our control plane components. It says current cluster version is 1.29.6 and you have chosen to change the cluster version to 1.30.2, right? So this is correct, and let's hit Y and it will do those changes. Now after that we have to upgrade kubelet and CNI provider. Let's have a look. It says manually upgrade your CNI provider for other control plane node. If we have multiple control plane node, the step is not required on additional control plane node if the CNI provider run as daemon set. Okay, all right. I guess we were already using the latest version of CNI provider, so that shouldn't be an issue. Now, if you have multiple control plane nodes, then you can run this command on the first node. No, sorry. And like on the first node, you have used this command, but on the other control plane nodes, you can just run this command, kubeadm upgrade nodes, if you have other nodes. Okay. Now, before upgrading kubelet and kubectl, we have to drain the node. Okay. So I'll just wait for few seconds while the control plane components are getting upgraded. So I'm going to wait for that. I'll just pause the video. Okay, after a couple of minutes, now it says success, your cluster has been upgraded to 1.30.2. So if I run kubectl get nodes, I will still see 1.29.6 over here because this is not the control plane version. This is the kubectl version that is coming from this reply, right? So if we want to check the components of control plane, you know, where is the manifest? There are different ways through which you can verify that, but you can go to our manifest folder, kubectl, sorry, it edc kubernetes manifest, and there'll be all the manifests. So if I do a sudo cat on kube api server.yaml, and over here you see where it says image, you see the image version has been changed to 1.30.2, and the same will be there for other control plane components as well, right? So you can verify that. Now our control plane is upgraded. Now the next step is to drain the node. Okay, so let's run kubectl drain, and node is master node, and let's hit enter. Now it says codon. I specifically did not run the exact command from the document because I wanted to show you something. So it says master has been codon. So if you remember when we were discussing about drain command, I told you that it's gonna codon the node. That means it will evict the pods running from that node and it'll move it outside, and then it will drain the node and cordon the node. So it will evict all the pods, and then it will also make it unschedulable. But over here it says unable to drain node due to cannot delete daemon set managed pods, right? And you have to use hyphen hyphen ignore daemon sets to ignore. So by default, this drain command has a pre-flight check which will restrict you to drain the node if it already has some daemon set managed pods running. So because we have Calico running over there and CSI node driver, it is not letting you to drain the node. So that's why we have to use this ignore daemon set commands if we want to, if we know what we are doing and if we are sure about it, right? So I'm just gonna add this, and now it's gonna evict the pod. It's gonna make it unschedulable. You see these, like there are so many pods that are in affected state because of the few tasks that I was doing earlier. So don't worry about it. If you don't see so many pods, you will see mostly a couple of pods. So that should be more than enough. Okay, so after a while, I had to run the command again because it was stuck somewhere. So I ran it again, and finally it says the node has already been coded and it has ignored those daemon set, and then the node is drained as well. So now if I run kubectl get nodes, okay, you will see the master node is now scheduling disabled. And if I ck get pods on the master nodes, so hyphen a, oops, k get pods hyphen o wide, okay, and if I do it on all namespaces, let's say, and there are few pods that are still running on master nodes. So we have kube controller manager and kube proxy, kube scheduler master, but I guess all the workloads have been moved away, right, including the daemon sets. So let's follow the next part now. We were over here, okay, we have we have okay, over here we have codon the node. Now we have to update kubelet and kubectl. So if I just copy it from here, and I'm using Ubuntu, that is why. If you are not sure, you can check it from etc releases, etc OS releases. We already saw that, and then you can follow these instructions for CentOS or RHEL or Fedora. Right. So let me copy the command over here. Okay, and let me just increase the font size, and over here I'm gonna use the same version 2-1.1. So let's replace this. Let's replace this as well. Okay, so what it is doing, it is just upgrading kubelet and kubectl with the newer version, the version that is same as Kubeadm and the control plane version. Okay, let's run this. Okay, and after that we have to restart the kubelet. So I'll show you. Okay, it's done. Now it says to run this command and then to restart the kubelet. This command, because kubelet runs as a systemctl service. So if I do systemctl status kubelet, okay, this is the status that comes from the kubelet over here, and it is running as a service, as a systemctl service. So it is referring this kubeadm.conf file, and here are all the logs. So if there are any error, it should be visible over here down. Then we have to run the daemon reload command so that the changes will be persistent for the reboot as well. So I'll run this command, and then I'm gonna run restart kubelet. Okay, kubelet has been restarted. Now let's see the status of kubelet. It is running, and if I do kubectl get nodes, the nodes is still not ready status, but if you see, the version has now been updated to 1.30 for master node because we have updated the kubelet. So this version is coming from the kubelet, and if you see kubectl hyphen hyphen version, I guess that's not the command. It should be with the client option, but let me see. So kubectl, Okay, kubectl version, and the version is 1.30.0 for kubectl client as well, right? So we have upgraded that. Now uncordon the node, so that will make it schedulable again, and so that it can accept new pods as well. So kubectl uncordon and then the name of the node master. Okay, it's uncordon. Run kubectl get nodes again. It is now in ready state, and we don't have that message which says unschedulable. It is schedulable now. Okay, master is done. Now we have to perform the steps in worker node. So there are different steps for Linux and for Windows. So we'll be following this step for upgrading the Linux node, as Linux is what we are using. So again, same thing. We have to change the repository over there. So I'm gonna go in my worker node. This is my worker node. Okay. And over here, first I have to check the package. So it was, let me update it, sudo vi etc apt, and then sources dot list dot d kubernetes dot list. Okay, and let's update it to 1.30. Okay, it's done. Now over here in the worker nodes, we only have to upgrade the clients like Kubeadm, kubectl, and kubelet. So that's what we are doing. And to upgrade kubelet, we just run the upgrade node command, right? So let's run these command first to upgrade Kubeadm. Where is the command for? Here it is for Kubeadm. So let's run this. Oops, again the issue with the single colon. Okay, this is done. Now upgrade node to upgrade the kubelet. Okay, actually it does not upgrade the kubelet, it upgrade the local kubelet configuration. Okay, upgrade the kubelet command is same as what we have used earlier. So now we'll be draining the nodes. Kubectl drain, node name is worker01, and then ignore daemon sets. Okay, it is throwing error, maybe because it does not have a kubeconfig. Okay, we can run the command from control plane node as well, or you can copy the uh, kubeconfig from control plane node to worker node. But let's just run this command from the control plane node because we are specifying which node we want to drain. So it will take care of it. Let me copy the command from here. It's not allowing me to copy the command, so it's okay. I'll just write it down over here. Kubectl drain worker01 hyphen ignore daemon sets. Okay, it has evicted the pods from worker node 1, and it has cordoned it, and now it has drained it. So if I do kubectl get nodes, I see scheduling is disabled and worker node 1 does not have anything running now. So this is why worker node 1 is out of maintenance now. Okay, so now let's proceed further, and now let's upgrade kubelet and kubectl. We'll be using the same command. Okay, let's run this. And once that is done, we'll just restart kubelet and then uncordon the node. Okay, now kubectl uncordon, name of the node is worker01. Okay, now basically same step but for worker node 02. So kubectl get nodes, if I do, node 2 should be ready. And now you see worker node 1 has not been updated with the latest version. Something is not right. Oh, because we have to restart. Okay. We have to run these commands on the worker node, not over here. Here we have already updated, right? So I'm just gonna copy the command. That is why it was not showing. So let's run this over here. Okay, and then we'll do the daemon reload and kubelet restart on the worker node. Okay, now if I do sudo systemctl status kubelet, okay, it is running. And now let's go back to our control plane node and okay, let's run kubectl get nodes. Okay, now it is updated. So our master and worker node 1 is now on the latest version. Now only the last worker node 2 is pending. So let's run the command quickly over there as well. So first we'll drain the node. Okay, let's follow this document. Okay, first we have to change the packet repository details. So the file that we have updated over here. So let me just copy the command from here. It was sudo vi. Okay, this one. Let's copy it and let's execute that in worker node 2. Shift A to get at the end last line and then update it to 1.30. I'm gonna do it fast now because we have seen already in multiple nodes. So this should be familiar now. So this is done. Now done upgrade worker nodes, Kubeadm. So let's run this. Okay. Update the single quote. I should have updated in the text editor itself, but okay. Once that is done, you can run kubeadm upgrade node command to update the kubelet local configuration. So yeah, that is done. Now drain the node. Again, you can drain it from the master control plane node. Drain, and node name is worker02 fun hyphen ignore daemon sets. Okay, then we have to upgrade kubelet and kubectl. Okay, and then we have to run it on worker node 2. Okay, so if it is getting confusing, like which command to run on control plane or which command to run on worker node, just remember this. We use kubectl utility to interact with the control plane API server, right? So that kubectl command can be run from the control plane node, right? And all the other commands like kubeadm, kubelet upgrade, and all the other commands should be run from the worker node. So that's the main thing about it. Okay, now let's run these two commands to restart the kubelet. Okay, and let's just uncodon the node from the control plane because we are using kubectl. Kubectl uncodon worker 2. Okay, uncodon. Now if I do kubectl get nodes, okay, I see everything is now on version 1.30.2 and all the nodes are ready. And then that's it. That's the whole upgrade process. And now our kubectl, if I do kubectl version, you will see kubectl is also 1.30. If I do kubeadm version, kubeadm should also be on 1.30.2. Here it is. And if I do kubelet.version, kubelet version, kubelet is also on. Okay, that's not a command. So hyphen version or hyphen hyphen version. Okay, 1.30.2. So everything is now upgraded. So that's the whole upgrade process. We have to upgrade the control plane components. We have to upgrade all the clients and kubectl, kubeadm, kubelet, everything. And then the cluster will be successfully upgraded to a desired version. All right, so that's it for this video. I hope actually this video it went longer than I anticipated because I don't know why, but I'm sure you were able to do the upgrade successfully by yourself. If you have not follow along the video, there is a task for you in the GitHub repository. Try to complete that. Try to practice node draining, cordoning, uncordoning, and basically performing the upgrade on control plane and master node, try to install a specific version of Kubernetes and see if you are able to upgrade it or not with the steps that we have followed. Details are there in the documentation and it will be there in the GitHub repository. So you should be able to do that. If you face any issue, you know how to reach out. We have the YouTube community, comment over here and I will try to get back to you as soon as possible. Or you can reach out to us on the Discord community server. Over there as well, there are amazing people that will be ready to help you anytime. Right, so thank you so much for watching. Try to complete the target of comments and likes for this video so that I can publish the next video tomorrow. So if we do that, thank you so much for watching and I wish you have a good day. Happy learning.